sec, guys.
Should we get started?
Yes. Good morning or afternoon, depending on where you're tuning in from. I'm Dane Christensen, the Digital Marketing Manager at GridGain Systems. I want to thank you all for taking the time to join us today for Apache Ignite Coding Examples webinar, Part 2, with Dmitry Sitrakin, who is one of the founders at GridGain Systems, as well as a member of the Modeling Project Management Committee for the Apache Ignite Incubating Project. But before we get into Dmitry's presentation, I have just a few quick administrative points to make. Dmitry will be demonstrating several coding examples for about 40 minutes, after which we'll have about 10 to 15 minutes for Q&A. Now, you'll notice that just above the presentation screen is a questions button. Click there to ask a question at any point during the presentation, and Dmitry will respond to your questions during the Q&A segment. Now, we may not have time to get to all of the questions during this event, but we'll definitely answer all of them afterwards. So please take advantage of this opportunity to ask questions from an expert in the field. Also, if you would be so kind as to rate the webinar and or leave any comments in the questions area toward the end of the hour, that will help us to improve the material for future webinars. So with that, we're ready to turn the floor over to Dmitry Sitrakin. Dmitry?
Yes, thank you, Dane. My name is Dmitry Sitrakin. I'm one of the founders of GridGain Systems. I'm also on the PMC committee for Apache Ignite projects. I'm one of the commuters there as well. So thank you all for coming, and thank you all for listening. This is a part 2 webinar of the coding examples with Apache Ignite. Last time we've been able to show some cool examples using data grid and compute grid functionality. And I don't think I wanted to get to streaming, but I don't think I had a chance to get to streaming. So guess what? Today we actually are going to get to streaming because we are going to start from streaming example, and we're going to look at streaming and CP example. We're going to do a pretty cool word count example because everybody else does word count, so why should we be any different? And we are going to show sliding windows for this word count and how to use SQL queries while the data is being streamed into the system. And the second example I'm going to show, hopefully I'm going to have time, is our service grid example, which will be shown in the context of the streaming example, but then we will deploy our streamer as a service, as a cluster singleton service, and show the advantages of doing that as well. So again, just briefly, I usually start with this jigsaw puzzle, which shows most of the Ignite components provided by Ignite. The main message here is that Ignite is not just a distributed key value store in memory, so it's not a distributed cache, even though data grid is probably one of our biggest components, and it provides transactions on caches, queries for caches, et cetera, et cetera. It's just one of the components we provide, and there are more. There's also a compute grid, which is all about executing map reduce and fork join type of queries on the cluster in load balance and fault tolerant fashion. There's service grid, which we'll be showing today. There's streaming. There's file system, messaging, events, data structures, et cetera, et cetera. So Ignite is actually a collection of independent components. But when you use them together, the advantage you get is that they're very well integrated with each other. For example, if you're sending a computation to a cluster and your computation needs to work on a data, that computation will go to exactly to the nodes where the data resides. If you're sending, the same goes for streaming. If you send, the streaming is very tightly integrated with data grid and with compute grid, et cetera, et cetera. So all these components are very well integrated with each other. You never have to use all of them. You usually start off with one or two and then add more as you get into more advanced use cases. So let's get started with our streaming example. Streaming is all about actually ingesting large amounts of data into Ignite caches, into Ignite distributed caches. And don't think about streaming that you always have to have a continuous stream of the data. Streaming also works very well with a finite data set. For example, if you have lots of data sitting in your Oracle database or maybe in Amazon S3 bucket, and you just want to store, you want to populate Ignite cache with that data, you would use a streaming approach. You would use our Ignite Data Streamer API, and you would start populating data that way. However, the cool thing about Streamer is that it actually also works with a continuous streams of data. And so the data that you're streaming into Ignite will never end. It just keeps on coming. And as it comes, Ignite has to process that data in parallel and provide capabilities to query that data and provide event notifications, maybe persist that data. So all of that is available within Ignite. So as the data is coming in, you have to be very sensitive to the memory consumption, because if data never ends, you do not want to run out of memory. So for that reason, you probably would set up a sliding window into which you would query. And sliding window is a window that goes into some time back and allows you to query data in that time frame. For example, you can create a sliding window over 1 hour, over last hour, over last day, maybe over last week. Maybe you want sliding window that goes over last 1 million cache keys that you have stored in the streaming. So all of that is possible within Ignite Streamer, and we actually are going to be showing an example of streaming words into a sliding window and querying those words in parallel. So one of the differences with the Spark streaming, that Spark is what they call, like you can pronounce the word correctly, is discretized streaming, which is essentially streaming streaming data into the Spark one RDD at a time. So it just batches them as RDDs, and you can process only one RDD at a time. In Ignite, you actually stream data into the Ignite caches as it comes, without any grouping or batching of that data. So as the data is coming in, it goes into the Ignite caches. So it's actually the real streaming you get with Ignite, and because of that, you actually can process thousands upon thousands messages per second in Ignite. And actually, we will see it here, because we are going to print out how many words per second we can process. So let's go ahead and get started with example. Before I do that, I want to show where you can download the latest version of Ignite. So if you go to Ignite website and you go to the download page, you will notice several download sections. One is third-party binaries, then official Apache Ignite releases as well. So the difference with the third-party binaries, it's a generally GridGain community edition, is that it's probably about 2-3 weeks ahead of official Apache Ignite release. And that's exactly the one we're going to be using here. We just released version 104, so I'm going to be using for this example demonstration GridGain Community Fabric 104, which in 2-3 weeks will become Apache Ignite 1.1.0 version. So let's go ahead and get started. Apache Ignite comes with a set of examples, which I already have imported here. And we are going to be looking into the example package. It's a POM-based package, so all you do is import the POM file. And we are going to be looking into streaming word count package under our examples. There are 3 classes here. Let me close everything out. There are 3 classes here. One is cache config, another is query words, and another is stream words. So they actually doing exactly what they're called. The stream words class is responsible for streaming data into streaming words into Ignite cache, and the query words will periodically query that cache as the data is coming in. So let's actually take a look at the code that we have here. It's a standard example, but that comes with Ignite, but it's a new example that was added. It has quite a few changes from the previous version of this example. So first and foremost, we bring up an Ignite node. We then create a cache, and we configure a cache with sliding window. Let's go ahead and look at configuration of the cache. Again, essentially we call this cache words, and we define sliding window by setting an expiration policy of 1 second into the cache. And we also create indexes, and they become important when we will be doing SQL queries into this cache as well. And I'll talk about them as well. So let's go back and look here. So the caches are dynamic. If what this line of code does is essentially it says, if cache does not exist, create it within the cluster. If it exists, please go ahead and reuse the same the already existing instance. So we add a cache, we create a cache, and then we create a streamer for that cache. And the streamer, the only parameter you need to create a streamer is the cache name, and we pass the name of the cache we just created. And after that, this code is all about, by the way, let me enable line numbers. This code is all about reading a wonderful book that I have stored here called Alice in Wonderland. I'm not going to go through the text of that book, but if anybody is interested, I can send you a copy afterwards. So we are going to be streaming the text from this book into the cache. So we're going to be reading this book line by line from a file system. And for every line, we're going to split it into multiple words using a space separator. And if if the word is not empty, if we didn't have two spaces in a row, then we add it to Ignite. So this is the only line of code that is required to add data into Ignite Stream. And the way we add in them, we should actually focus on this line a little bit. The way we add in them is we create a unique key for each word, and we put that word into cache for that key. We only have Ignite caches work with keys and values. Just we only have a word as a value. How do we create a key for that word? And how do we make sure that all identical words end up on the same node for faster processing? Because we want to collocate identical words together so we can count them faster. So for that, Ignite has a cool abstraction called Affinity UID. It essentially will generate a unique key for you, globally unique key. But if you pass in the word into it, so it will collocate that key with this with the parameter you pass into it. In our case, we pass word as a parameter, so it will collocate the key with the word we're storing in cache. So that's what we do to stream the data into the cache. Let's go ahead and get started on that. We're going to start a couple of nodes. This is how you start an Ignite node. You can start it from a command line, or if you want to start it from code, all you need to do is call ignition.start, and you pass a configuration file if one is needed. Otherwise, Ignite will start with all defaults. So let's go ahead and start example node startup. Start that first instance. And I'm going to start it up again, so we're going to create a cluster. All right, so both nodes discovered each other. The printout is that we have two nodes here. And let's execute our streamer. Let's execute our streamer, the stream words process that we just talked about, and run it. And it's going to start up, it's going to join the cluster, and it's going to stream words. Nothing is actually happening as far as printouts go, because all we're doing is streaming data. How do we know? We look at our CPU utilization, and we see that cluster is very busy. My laptop is actually about to, I think, smoke. Smoke is about to start coming out of my little laptop, which I'm using for this presentation. But the data is being streamed. So now let's actually query that data that we're streaming into the Ignite cluster. For that, we use standard SQL. As the data is coming in, we're only keeping one last second of that data. We want to query into that data, and we want to get 10 most popular words of that data. So for that, we define a couple of queries. In Ignite, we use standard SQL. Tabs become tables, fields become columns. So in our case, the type is a string, so we use that as a table name. It's a box type. It doesn't have any fields. So for types of this kind, for box types, Ignite provides its own field name called _val. So this is the nature of our query. We select val and its count from string. We group by val. We order by count in descending order because we want the bigger the count, the more we want to show it. And we limit to only 10. And the last parameter is tells Ignite that all words are collocated, so Ignite can apply some optimizations to make the for the collocation mode. On top of that, I'm actually also going to execute another SQL query that select some averages from the cache as well. We're going to select average count, mean count, and max count from this is where the cool part comes in, from a nested SQL. So first we select count for each word, and then we select average, mean, and max from that nested SQL. And we're going to execute both of these queries. This is how you execute them. So now we define these queries to SQL fields query. This is how you would execute them. So we take our cache, and we call query method, and we pass our query into it. Queries results returned in paginated form. In our case, we know we only return 10 results, so we don't need to paginate, so we call get all, and it will return the whole thing. And then we just nicely format it, and we print query results. So first we print averages, and then we print query results, and we execute this query every 5 seconds. So I'm going to go ahead and run this. Taking a little bit of time, my laptop is very overloaded. I'm doing a webinar. I'm running a very CPU-intensive streaming example, and I'm also starting a query example. So our query node just joined the cluster, and here we start seeing query results coming in. Some mean, max, averages, and the results are being printed out as they come in. The reason you're seeing some discrepancy between maximum value in the results and the value in the top word is mostly because these two queries are executed separately from one from each other, and there's a lot happening in between these executions. So now we have our results are coming in as well, and we periodically get 10 most popular words that are being stored in Ignite. So pretty cool. One thing I want to mention here is that the caches are fault tolerant. The words can be backed up, and you can define as many backups as you need. However, what if our stream, what if the node that actually does the streaming crashes? What happens then? So let's go ahead and kill it. The streamer has been closed, and the query results becomes empty. So there's nothing to query because the sliding window of 1 second is expired for all the data, and we have no more data to query. So not very cool when it's not very cool when you're actually working in production and you want your streamer to also survive crashes. So how do we guarantee it within Ignite? And that's where Ignite cluster services come in. And let's go ahead and talk about cluster services a little bit, and then I'll show how to create a cluster service as well. So cluster services Ignite services are defined in a component called services or service grid. And this diagram actually shows very well what's the difference between, the picture shows very well the difference between cluster singleton and node singleton classes. Essentially, service grid is all about defining different singletons on the cluster. That's the main application of it. So cluster singleton, as you see, will have one instance on the cluster in a guaranteed fashion. And node singleton will make sure that every node has that instance. There's also a key singleton, which will guarantee that service is attached to the key. So in case of rebalancing, and if a key travels to another node, the service will travel with that key to that node as well. So the access to that, so it will always be local to that key. So singletons is definitely the main use case, but you don't have to deploy singletons using Ignite Service Grid. You could actually say, I want to have 3 instances of some service deployed. And Ignite will guarantee that you will always have 3 and only 3 instances of that service deployed. So that's where guaranteed availability comes in. So let's take a look at the coding example where we will define our streamer just like a cluster singleton and make sure that it is deployed in a fault-tolerant fashion. So I'm going to go ahead and switch to my IntelliJ screen. And we're going to keep this guy running, let it keep returning empty result set, not bothering us. Maybe not bothering us a lot. So let's go ahead and start defining our service. First, we can start off with an API. We're going to create a Java service API. And your service does not have to have an API, but we're going to demonstrate how to create one. So let's call it streamer service. And the API will be, let's actually calculate number of words per second with processing. Public int get words per second. So that's the API for our service. So now let's implement that service. To implement that service, first I need to create a class that is implementing it. So streamer service input. So to implement a service in Ignite, all you need to do is specify this interface, implement service interface. And since we also defined our own API, so we also want to implement our streamer service API as well. Streamer service. So let's go ahead and implement these methods, the methods required by these interfaces. So these are the methods that are required. The first three methods are dictated by Ignite service interface, and the last one is our streamer service API. So to satisfy the last method, we need to have total count of words, and private int start time. Oh, actually, it's going to be long, and private long start time. So now we have defined that. Let's actually keep going and copy some code that we defined in our streamer class over here so we can deploy it as a service. In a cancel, let's print out some notifications here. So first we'll print out that if service was canceled, we want to see it. I'm going to print out the name of the service. Then to initialize, we want to initialize the same cache as we used in a streamer. So I'm going to go here and create this cache as a variable. And this is how we're going to initialize it. Exactly the same code as we used for streamer. By the way, Ignite, we don't have an instance of Ignite in our service, so how do we get it? We inject it. So GridGain supports, Ignite supports auto injection for all the artifacts provided by the fabric. So we're going to call it Ignite, and we are going to inject it, Ignite instance resource. And Ignite will automatically inject the instance of the Ignite of the main Ignite API into this class. And since we initialized our cache, we want to print out that we initialized it. Service is initialized. And let's actually put some execution logic into our service. And again, I'm going to grab it from here and copy it into our service, because it's the same service we're deploying. We're just defining, it's the same logic we're deploying, we're just defining it as a service. So the only change I'm going to put in, a couple of changes, is one will be, we don't want to go past the cancellation. So if the service is canceled, we want to stop. And I'm also going to catch cache exception here. And if it was not interrupted, then I propagate it. But if it was interrupted, then I'm going to ignore it. That's it. So we are ignoring interrupted exception. So if we kill the service, we don't care about it. If it's a real cache exception, we want to throw it. So those are the only two changes. And the last method we need to implement is get words per second. And that is actually, to do that, we need to first start counting the words. That will be done here. So words plus plus. So now we're counting the words. We need to also record the start time of our service. So let's initialize the start time. And now let's calculate words per second. So what is words per second? It's total number of words divided by current time minus start time. And one thing, we want to do long, not int. And since this is giving us time in milliseconds, we want to multiply by 1,000 to get time in seconds. That's it. So that's our implementation of our method. So now we got our service defined. Let's look at how we are going to deploy it. Before I actually move away from the screen, I want to go briefly again of what has happened here. So service, Ignite Service API provides 3 methods that you are required to implement. That's cancel, init, and execute. Cancel is where you're handling the cancellation logic. We don't really have any. Init is where you do any kind of service initialization. In our case, we just get a handle on the cache if it hasn't been created. And in execute, we actually perform the logic of our service. And then in our logic, we essentially just reusing the same logic as we did for the streaming. So we keep streaming data into Ignite, and we're counting words, we're counting locally processed words as well. And then last method is the one we added to the API. This is the one we will be using from public API. Get words per second, and we're just calculating the words per second. So let's go ahead and deploy this service. We are going to create another Java class called streamer service example. And I'm going to copy again the logic for starting Ignite so I don't make any demo mistakes. Oops. I'll do public static with in. And now we'll do start an instance of Ignite. And inside of this instance, we deploy service. Before we do it, we want to specify that we don't want the service to participate, this node to participate in anything, so we define it as client. So now we get let's get an instance to the service API, Ignite services. And we want the services to work only on the server nodes and ignore the client nodes. So we pass a server cluster group into Ignite cluster or servers. So this actually will create a cluster group only for server nodes, and we pass it in. So services will only be deployed on the server nodes. And last method is we deploy the service on the grid, and we do services. Deploy cluster singleton. We give it a name, word streamer service, and we pass in our implementation called streamer service simple. That's it. So we're ready to go. Let's go ahead and deploy the service. Note we still have this guy running. example node startup, and the query words is actually returning empty result set. The stream words is stopped. Okay, so let's go ahead and deploy the service. This is, by the way, all you need to do to deploy service. Just call this method. Alternatively, you can also deploy it from XML if you want to do it from configuration. All right. We deploy the service and exit it. And the streaming started. I believe I'm not printing out anything from execute method. Yep, I'm not printing out from execute method. So we got services initialized. This indicates that the service has started on this node. It's a cluster singleton service. And this node does not have it because it's a singleton. So only one of the nodes should have it. Let's look at the query results. Now we're getting some query results again. And we're getting the most popular words again, and the query continues to work just like it was before. So now, the difference here now that our service is fully available, so our streamer can survive crashes. So let's go ahead and see what happens. So streamer is deployed on this node, and we know this because of this printout. Let's go ahead and kill this node. Service is canceled, node is stopped, exited, boom. Service is initialized on this node automatically. And demo effect, queries should be continuing to work. So I messed up somewhere in my demo, but queries are continuing to work, should be continuing to work. Always happens during the demo. And the results continue to come in. It's going to warm up. It's going to take a little bit, and we're going to start getting more words in the service. By the way, we only have one service running. So again, this ensures the availability of the service at all times. The service had actually 0 downtime. I'm sorry for the error in my query words example, but as we're seeing, the service is still coming in, and the data is still being queried. The service, after we killed this node, the service was automatically deployed on the other node. So we get this continuous query execution without interruption. So now I'm going to actually allocate, I finished a little earlier, so I have a little more time. So I'm going to go back to my presentation, and if you have any questions, I'm going to open it up for questions.
Hey, Dmitry. Yes, we do have some questions here for you from the group. Just give me a second to get over to those.
By the way, I'm going to kill my streamer because my laptop is really struggling.
Okay, so here's a question for you, Dmitry, while you're waiting for that. Would you provide a simple example of inspecting the data grid using the Ignite Visor command line tool? Now, that might be something you have to demonstrate.
Yeah, that would be something for the next demo.
Yeah,
that would be something for the next demo.
Oh, okay. The next demo today?
No, it actually will. There's another coming up in a couple of weeks where we'll be
for the next.
Okay. Benchmarking of data grids, and on that one we will be showing. I can show that as well.
Okay. All right. Then here's another question for you. Does the Affinity UUID ensure that all instances of the same word will end up on the same cache node?
So the question is, what does Affinity UID represent? And the answer is yes. Essentially, it is a globally unique key, but when you pass in a word into it, you guarantee that all keys that have the same word will be cached on the same node. And that allows us to count the words a lot faster rather than distributing them across multiple nodes. And in that case, the query would actually become less efficient.
Okay. Let's see, we have a couple other questions here. So here's a data grid question. On a cluster with multiple nodes, how do you control which nodes a cache lands on without using specific host attributes? Let's say I wanted to create a cache on 6 of 100 hosts, but I only know which host when my application launches. Is the cache name sufficient enough to create this kind of grouping? Data grid question, not compute grid. So that was kind of a long one. I hope that made sense.
Yeah, so the question is, how do we control topology on which we initialize the caches? And the answer is you would pass in, cache configuration has a node filter parameter. So you can pass in a node filter or topology filter, and it will only be deployed on the nodes that pass through that filter. So this is so if you want to deploy it only on the nodes that in a certain subnet or have a certain attribute or have any other criteria, you could define a filter for it and specify it in cache configuration, and the deployment will happen automatically.
Okay, great. Now, let me know if you're still wanting more questions. Are you still waiting on something?
No, there's nothing I'm waiting for. I just realized
okay.
I actually did not show a little bit of the example, but let's keep going through the questions, and if I have time at the end, I will continue with the example.
Okay, I'm sorry, Dmitry, did you say you were ready for more questions? Sorry.
Yes, if you have any more, otherwise I can continue and show one more piece that I wanted to show.
Yeah, there are a couple more questions, and by the way, for the audience, feel free to ask your questions because normally we take them at the end, but it looks like we're taking a few as we wait for some things. Here's a question for you: do you tag the actually this might be related to that last one? Do you tag the information coming into the network?
That actually, I'm not sure I understood the question. Do we tag the information coming in? Yeah, I'm going to pass on that one. I'm not sure I understand the question.
Okay, no problem. There's a couple other questions here. Here's one. Is there a book coming out on Ignite, like Apache Ignite in Action?
Yes, it's currently in works, and so at some point it will come out. You just have to go through editing and a few revisions before it's going to be released, but yes, it's currently in works.
Okay, great. Here's another question. Runtime environments. Do you support running in a PaaS, platform as a service such as Cloud Foundry?
So the question is whether Ignite can run in a cloud-based environment or a PaaS-based environment. And the answer is yes. It may not be integrated automatically with all PaaS providers, but it will be always easily deployed into any cloud environment. Our clustering works across AWS, Google Compute Engine, any kind of JCloud compliant implementation of a cloud. So JCloud actually works with virtually most of the clouds out there, and we integrate with JCloud as well. So we can via that integration, we can actually provide cloud cluster discovery across most of the cloud providers out there. And once you do that, you can actually specify, deploy Ignite as an individual service, or you can actually deploy it as a service. And when you deploy it as a service, you would need some isolation. So generally, isolation is provided by caches. Tenant isolation is provided by caches, and you can create different caches for different tenants. And caches can be created on the fly, so there's pretty much, it's a very easy and operation you can implement during runtime. So for every new tenant or for every existing tenant, for example, you could create a new cache. And in this way, you can actually implement multi-tenancy quite naturally within Ignite as well.
Okay, great. And just let me know when you're done with Q&A here, Dmitry, but we've got a number of questions coming in, so I'll go ahead and keep asking the questions as they come in. So this is related to the question that you answered just a little bit ago on the data grid. What if you don't know the filters or attributes beforehand? And did you want me to repeat the previous question?
No, it's actually
the other.
If you do not know on which servers, I mean, you have to know if you want to specify the topology for the service you need to deploy. You have to provide us with that information. If you do not need them beforehand, but you can get them during runtime, then you can dynamically create a cache during runtime and specify the service on which the cache is deployed. Once the cache is deployed on a specified topology with a filter, and the filter is, by the way, dynamic, right? So as new nodes are coming in, they may also be accepted by the filter, and in that case, the cache will be automatically deployed on those nodes as well. But you have to let us know what kind of nodes to accept. So otherwise, we do not know exactly where you want to deploy a cache.
Okay, great. Here's a good one. Are you included in Apache BigTop?
In Apache BigTop? Yes, so BigTop is a very cool project which allows easy installation of different big data products. Hadoop being one of them. Apache Ignite is also one of them. So you can use BigTop to easily install Apache Ignite. And whenever you actually do that, it integrates with Hadoop automatically, with BigTop Hadoop installation automatically, and provides immediate optimization for Hadoop using Apache Ignite in-memory MapReduce and in-memory file system. As a matter of fact, another webinar will be coming up when we'll be showing the cool demonstration. You could execute a pi calculation example provided by Hadoop using standard Hadoop or the version of Hadoop accelerated with Apache Ignite. And Apache Ignite can provide more than 30 times faster execution.
All right. More questions, Dmitry? We've got more questions.
Well, if you have any, I'm not waiting for anything. I can show a little bit like an additional portion of the example, but if you have more questions, I'd rather spend time answering questions. If not, I can move to the example as well.
You bet. Well, yeah, we're on a roll here, so let's go ahead and take a few more of these questions. In the streamer example, were you querying only the past 1 second of data in the cache? Additionally, was the data being added all retained in the cache or just passing through?
So we were, let me go back to the streamer example. And here we actually use configuration of the cache, and we set up the expiration policy on the cache to 1 second. So the data was passing through the cache, and the new data was coming in, and the older data that is more than 1 second old was evicted. The reason I defined the sliding window to be this small is because my laptop is small. So generally, you would probably go into days, hours, or days, or maybe weeks, or maybe you wish to limit it by size and say no more than 10 million latest entries. You can do that as well, and evict them in a FIFO fashion. So the data, to answer your question, the data was passing through. The new data is coming in, the older data was evicted from cache. But the query was real time. You were querying the real time data.
Okay, great. And so you know, we do have a couple more questions. There's a few more questions. I want to be sure we get all the content in that you were planning to get in, Dmitry. And oftentimes we don't have time for all the questions. So if there's something else,
let me go ahead and finish. Let me go ahead and finish the example then. So one last thing I wanted to show is we forgot to demonstrate how to use the API of the service that we defined. So I'm going to go ahead and print out number of words per second we were processing. And for that, I'm going to get instance on our service, which is the instance of Ignite services, first of all. And I'm going to get a proxy to our service, which was called Word Streamer Service. I'm going to specify the class name that we defined for our service, Streamer Service. And the last parameter doesn't matter for cluster singleton, so it will be ignored. So we assign it to Streamer Service API. And let's print out number of words per second as well. So system out print time, number of words per second. So here we're actually accessing our service from a client node. Even though service is deployed on a server node, we create a proxy for the service interface and access it from a client node. So I'm going to go ahead and start my example again. So now two nodes are started. I'm going to go ahead and deploy our service. So Streamer Service example was deploying our service. I'm reinitializing my example. And we're deploying service on one of the server instances. Let's go ahead and take a look. So service has been deployed on this instance. And the streaming is started. I'm going to look at the CPU load. And the CPU load is coming in. So my laptop is, again, fully busy doing two top-level processes are the two Java processes that we started, and we're streaming words into the caches at a higher rate from within one of the services. So from within one of the cluster singleton services we just defined. And now if we issue query words, start querying, we are going to print out number of words per second as well. So let's go ahead and do that. So it's about 18,000 words per second when I'm running webinar. When I wasn't running webinar, I was getting about 35,000 words per second. So webinar is definitely adding some overhead to what we're doing here, but this is essentially the amount of it gives you a picture of the rate of data you can pump into the Ignite streamer. So we're actually pumping right now over 20,000 words per second. And again, this should continue if we kill the service. And it didn't work again. So something is wrong with my example. But it's only the querying part that I have somewhere misconfigured. And so the query, we can continue querying. So the data is continuously being streamed into the cache, and we can continue to see results even if we kill the service. And now we still can see that we're processing about 23,000 words per second. All right, so this was the last part of the example that I wanted to show. Access to the service API from client nodes. Here's what, just to summarize what we've done here. We defined a proxy for our service. we defined it from our client node, the same node that is issuing the queries. And we're accessing public API of that service deployed somewhere in the cluster from a client node by proxying the calls to the server. So each invocation to get words per second actually goes to the node where the singleton service is deployed and executes this method there. So that concludes everything I wanted to show. If you have any more questions, okay, I can take them.
Yep, excellent, Dmitry. There are just a couple more questions, and I think we have just enough time to answer those questions. Here's one. Can we have a cache loading data from underlying DB store? Can we optimize the data stored in the cache and still have query working some ORM layer? Did that make sense?
I think there are several parts to this question. So the first part is, can we load the cache from underlying data store? And the answer is yes. Ignite can be configured in a read through, write through, or write behind scenario for the any kind of underlying data store, be that a relational database, a NoSQL database, or a plain file system. You can read through that, read from that store, and write to that store automatically. So that was the first part of the question. So you can preload the cache from that store as well. And Ignite again has a cache store API responsible for integration with any kind of any store out there. And from that cache store API, you can load the data automatically from underlying data store in bulk as well. As far as queries and once the data is loaded, you can actually start querying it. I'm not sure what was the last part of the question, but once the data ends up in memory, you index that data and you can query it immediately, and you can query it very fast. As you saw, we were querying data coming in at about over 20,000 of data elements, data entries per second, just on my MacBook Pro laptop. So the data can be coming in at very fast rates, and we can concurrently query it in continuous fashion as needed.
Okay, great. And then one more quick question here. The difference between extending from cache store adapter and cache store.
It's just adapter. So store has essentially methods like put all, where I can write all, load all, and delete all. So cache adapter will essentially provide default implementation for this delete all, load all, and put all methods by iterating through those through the collection and invoking the individual counterparts. So the put all method will iterate through all the keys and invoke put for each of those keys. So it's just a default implementation, but my recommendation for performance reasons, you probably want to specify an implementation of put all or write all methods that will do a bulk write into the underlying store versus many individual ones. So for to get quickly started, you can use the store adapter, but you probably will want to override some bulk operations if you're using them.
Okay, great. And then the only other question was that one about Visor, which you said you would cover in a subsequent webinar. So that is going to conclude the questions and the webinar for today. So we appreciate everyone tuning in to the webinar today, and compensating for our little technical issues there, but so we hope you got a lot out of it. As you can see on the screen there, we did want to make you aware of the first ever In-Memory Computing Summit that's coming up on June 29th through 30th in San Francisco. The event's sponsored by a lot of the leaders in the in-memory computing space like SanDisk, NemSQL, DataTorrent, Scale-Out Software, and of course GridGain, with some of the top experts in the field speaking. And there's still time to get some early bird discounts, so check out the discount code there. and visit the website, and you'll see that discount code and the URL in the PDF version of the PowerPoint presentation, which you can see in the attachments area. So that will do it for today. Thanks again for attending, and have a great rest of the day.
Thank you. Thanks everyone for attending.